I want to talk to you right now about naming and drawing alkenes. Actually, we're going to talk about alkynes as well. We're going to focus most of this video on alkenes. Now, alkenes are very similar to alkanes apart from the fact they have double bonds in them. So, if you remember when we talked about naming alkanes, the way to tell it was an alkane was that they had the letters A and E on the end for alkane. For alkenes, it's very similar, except the letters on the end are E and E, and then for alkynes, the letters on the end are Y and E. So alkane, alkene, alkyne. So we're going to focus on alkenes right now. I told you before that you need to have a grasp of the basics of naming alkanes, because we're going to use that here and build on it. The reason why we're going to build on it is because we're introducing something that we haven't seen before. We're introducing a double bond. This introduces a bit of a level of complexity that we haven't seen before. However, the rules that we've been through previously are still exactly the same in terms of numbering and all that stuff. So we want to ask ourselves, well, which side do we start numbering from? Well, in this case, the only real difference is that because we have this functional group here, this double bond, this takes priority over all of the substituents. Alright? In other words, when we come to decide which way do we name it, we don't go off which substituent we come to first. We go off from which side do we reach the double bond first, and we then put the substituents relative to that. So you can see that if we go from the left hand side, 1, 2, 3, 4, 5, the alkene starts on carbon 5. If we go from the left side, from the right side, sorry, it's 1, 2, 3, 4. The alkene starts on carbon 4. So we're going to go from the right because 4 is lower than 5. Also, if we go from the left, we have the alkene starting on 5, sorry, and the methyl being on 7. All right, and here we've got 3 and 4. So the first thing I'm going to do before we name it is convert this into a line structure. So to do that, I just want to draw out all the carbons in my parent chain. So I have 9 carbons, so that's nonane. And I'm going to draw that out in the zigzag form. So 2, 4, 6, 8, 9. 2, 4, 6, 8, 9 carbons. Okay. Yeah, I can see coming off carbon 3 is a methyl group, and then coming off carbon 4 is the double bond. So the only thing to remember about the double bond is if you had a double bond in this structure, then draw one in between those 2 carbons in this structure as well. It turns out that you can draw double bonds different ways, but I'm not going to focus on that now. That's going to be for the next video. For right now, I just want you to understand here's where the substituent is, here's where the double bond is, and we name it based on where the double bond is rather than the substituent. So if I just put our numbers on here, 1, 2, 3, 4, and 5, you can see the double bond exists between carbons 4 and 5. However, we don't need to include number 5 in the name. If we say it starts on 4, then it's assumed it's also in 5 because the double bond is always present between 2 carbons. So what's the name of a 9 carbon chain? Well, we said before it's nonane. Alright, so the name is going to be based on nonane. However, we don't have an alkane, we have an alkene. So that means our name is not going to be based on nonane, it's going to be based on nonene, because we have an alkene. And the other thing we have to make sure the reader understands is, where is that double bond in the molecule? Well, it starts on carbon 4, so I'm going to simply put 4-nonene. Because if I put the 4 here, then the reader understands that the 4 refers to the alkene. Now, if we just finish this off, and I say there's the methyl group on carbon 3, notice the position of the methyl comes before methyl, the position of the alkene comes before you say alkene, and before you say nonene. So that's why we have to put these numbers here. Alright? Just imagine how it would be if I wrote out this, 3, 4, methyl, nonene, and I didn't specify what I've specified here. The question would then come up is, well, what does the 3 refer to? Is that the methyl or the alkene? Is the 4 the methyl or the alkene? Here, you're not sure. Here, it's crystal clear. The 3 goes with the methyl, the 4 goes with the nonene. All right? So basically, that's the way we're going to be naming alkenes, although I want to go through a couple more examples. Now, take a look at this guy. This is kind of a funky looking alkene, but the principle is exactly the same as what we've seen before. We need to find, as we found here, the longest carbon chain. Now here it was just a straight line. The thing I didn't tell you before, because it wasn't really an issue, is when you're naming an alkene, figuring out the longest carbon chain, you have to find the chain that contains both carbons of the double bond. Now here that's not a problem, but if we go to here and you say, well, the longest carbon chain looks like it's going to be 1, 2, 3, 4, 5, 6, 7 carbons, that's alright, isn't it? Well, the problem with that is going this way does not take into account both of the carbons from the double bond. So that means this isn't the right number of carbons in terms of the longest carbon chain. So I'm just going to get rid of these, as long as everybody is clear about why I did that. Instead, we need to make sure that we include both of those carbons, which means we have to count these two, which means our longest carbon chain is actually going to be 1, 2, 3, 4, 5, 6. So our name is going to be based on hexene. So when we ask ourselves the same question we asked before, which side do we start counting from the left or from the right? Well, if we count from the right, alkene is encountered on carbon 2. If we count from the left, it's encountered on carbon 4. So we're going to be counting from the right. So 1, 2, 3, 4, 5, and 6. All right. So just as we did before, the alkene starts on carbon 2, so therefore that's 2-hexene. But what is this group coming off carbon number 3? Well, it's a 3-carbon substituent. We've seen before 1 carbon is methyl, 2 carbons is ethyl, 3 carbons is propyl. And that's on carbon 3, so therefore the name of that is 3-propyl 2-hexene. Again, the 3 clearly goes with the propyl, the 2 clearly goes with the hexene. Let's have a look at this one here. If you take a look at this guy and ask yourself, well, first of all, where's the longest carbon chain that contains both the carbons of the double bond? Well, if you start counting from here, which you kind of have to do because that's the end of the chain, 1, 2, 3, 4, 5, 6 carbons, or 1, 2, 3, 4, 5, 6, 7. 7 carbons. So it's going to be based on heptene. Now, if I ask you the question, which side do we start counting from? Well, here it's not much of an issue because the alkene automatically starts at the end of the chain, so you would start the alkene on 1 rather than carbon 6. So we're going to go 1, 2, 3, 4, 5, 6, and 7. The alkene starts on carbon number 1, so we can say that's going to be 1-heptene. All right. But what are our substituents? Well, we have 2 substituents here. All right, we got this guy, our methyl group, and this guy, our ethyl group. The methyl starts on 2, the ethyl starts on 4. We already know which way we're counting because we figured that out before. The only other question is which one of these guys comes first. Well, of course, it's going to be the ethyl group because ethyl is alphabetically before methyl. So therefore, hopefully you can see this is going to be 4-ethyl. Don't run out of space here. 2-methyl, 1-heptene. All right. Hopefully that makes sense. Now, before I get to this guy, let me just go through one thing really quick. If I just draw this out. What about this one? It's pretty clear the longest carbon chain is 1, 2, 3, 4, 5, 6 carbons long. So that's going to be based on hexene. But you have to ask yourself the question again, which side do you start numbering from? If you notice, no matter which way you count, the alkene starts on carbon 3. So that could mean, well, does it matter which way I came from? If you can't figure it out from the alkene, then figure it out from the substituents. This guy right here. If you count from the right, he's on carbon 3. If you count from the left, he's on carbon 4. So it makes sense that you count from the right, because 3 is lower than 4. So therefore, can you see the alkene starts on carbon 3? The methyl group is also on carbon 3. 3-methyl, 3-hexene. Now this guy really quick, this is what's known as a cyclohexene. In a previous video and in a previous class we talked about cyclohexanes. Cyclohexanes are very similar, they just have a double bond in that ring. If you were to not have this double bond here, you would have something called methyl cyclohexane. Now introducing the double bond does make the numbering a little bit more complicated. Alright? So let's just figure this out. As before, we want the lowest substituent total, as we've always wanted. You know, there is nothing new about that. And if we want the lowest possible number for our double bond, because it takes priority over the methyl group, it would make sense to start numbering either of these two carbons. But then we've got to ask ourselves the question, well, which way do we number? Do we start here and go 1, 2, 3, 4? Maybe I start numbering here and go 1, 2, 3, 4, 5. Well, hopefully you can figure out which is the one that makes more sense. Of course, it's the lowest number, so we're going to go with the red numbering system here. All right. Now, the thing we have to be careful of is we have two things in this molecule. We have the double bond and the methyl group. We have to make sure, just as we did here, that the reader understands where the methyl is relative to the double bond. We're going to assume the double bond starts on carbon 1. In fact, that's what you would normally do in a molecule like this. So therefore, if I write that name out again, so we've got cyclohexene, and we're assuming that alkene starts on carbon 1. The methyl group is on carbon 4 relative to that, so therefore 4-methyl, 1 cyclohexene. Remember, the cyclo is there just to tell you that there is a ring there. Alright, so that's naming alkenes. A little bit really quick on naming alkynes. These are named in exactly the same way as for alkenes, except you use the suffix "ine" rather than "ene." Alright, other than that, they're named exactly the same way. You have to have the longest carbon chain containing both the carbons of the alkyne. So here it's going to be 1, 2, 3, 4, 5, 6 carbons based on hexane, but because it's an alkyne, it becomes based on hexyne. And again, you ask yourself, which side do I number from? Well, hopefully it makes sense you number from the left, because the alkyne starts on carbon 2 here versus carbon 4 numbering from the other side. Therefore, 2-hexyne. Now this one looks quite a bit more complicated, but before we go any further, I'm hoping you can see we're going to be numbering from the right-hand side, because the alkyne is much closer to the right-hand side. The right-hand end, I should say. So when we number these carbons, the one thing to make sure we understand is this. Remember when we talked before that every time you have the break and the slope of a line, that means you have a carbon atom. The only time that changes is when we have alkenes. The other thing to remember is even though all these lines are going in the same direction, when you change from a single bond to a triple bond to a single bond, this point of where there's the switch between single and triple means there's a carbon there. There's another switch from triple to single here, which means there's another carbon there. So anytime you have a triple bond drawn out in a line structure like this, between the single and triple bonds, there's a carbon on each side. So when we go through all these carbons, I think everybody will be able to see that we have 10 carbons in our alkyne. Alright. So a 10 carbon chain is decane, but because it's an alkyne it becomes decyne. Alright. And just as we did before, the alkyne starts on carbon 3, so therefore 3-decyne. However, we have our two substituents to worry about. We have this guy We've seen this before a bunch of times. We know this is methyl. We have this guy. We've seen this in the previous video. We haven't seen it all that much yet. It's a 3-carbon substituent. It's a version of propyl, but because all the 3 carbons don't go in a row from the parent chain, it's an isomer of that. It's isopropyl. I is part of the name here, so I comes before M for methyl. And then all we've got to do is put on our numbers. Alright. So the alkyne started on carbon 3, the methyl is on 6, the isopropyl is on 7. Isopropyl comes alphabetically first, so therefore what we have is 7 isopropyl, 6 methyl, 3 decyne. And that's the way naming alkenes and alkynes works. Alright? Simple as that.